We now discuss the solution of a problem from the differential calculus that appeared in JEE Main exam. The problem is on the continuity of a given function at x is equal to 0. This question has appeared in JEE Main examination held on 22nd July 2021 in the afternoon shift. The problem is, let f be a function from the set of real numbers to the set of real numbers be defined as f of x is equal to when x not equal to 0, the function is defined as x cube by 1 minus cos 2x whole square into log to the base e of the function, which is a quotient. Numerator is 1 plus 2x e to the power of minus 2x by the denominator is 1 minus x e power minus x whole square when x not equal to 0 and is equal to alpha when x is equal to 0. If f is continuous at x is equal to 0, then alpha is equal to, the four options are given to us. Solution. And we recall f is continuous at a point x is equal to a if and only if limit of the function f of x as x tends to a is equal to f of a, the value of f at a. F is continuous at x is equal to a if and only if limit x tends to a of fx is equal to f of a. F is continuous at x is equal to 0 will imply limit x tends to 0 f of x is equal to the value of the function at 0 f of 0, but f of 0 is given to be alpha. So the alpha is obtained as limit x tends to 0 of fx. So alpha is equal to limit x tends to 0 of this function fx. We continue. Alpha is equal to limit x tends to 0 of the given function. Now in this denominator 1 minus cos 2x is there. 1 minus cos 2x is 2 sine square x and 1 minus cos 2x whole square will be 4 sine power 4x, and that will be equal to limit x tends to 0 x cubed by 4 times in the denominator sine power 4x into the remaining function. Now we will adjust this sine power 4x as sin x by x whole to the power of 4, and to adjust that we multiply by x to the power of 4 in the denominator. So 1 by 4 limit x tends to 0 x cubed by in the denominator sin x by x whole to the power of 4. To adjust that we multiply by x to the power of 4 and the remaining function. And now this x cubed by x to the power of 4 will give you 1 by x. That 1 by x you send inside the bracket. 1 by 4 limit x tends to 0 1 by sin x by x whole to the power of 4 into inside the bracket logarithm of ln of 1 plus 2x e to the power of minus 2x by x minus 2 into logarithm ln of 1 minus x e power minus x by x. Now this is the first function. Whatever is there in the bracket is the second function. The limit of the product of the functions is equal to product of their limits. So limit x tends to a fx into gx is equal to limit x tends to a fx multiplied by limit x tends to a gx. So 1 by 4 into limit of the first into limit of the whole thing what is there in the bracket. So that will be equal to 1 by 4 limit x tends to 0 1 by sin x by x whole to the power of 4 into limit x tends to 0 whatever it is there inside the bracket. Now we recall limit x tends to 0 sin x by x is 1. So this is the formula what we have. So if I take the limit, it will be 1 by 1, it is 1. So what is left is 1 by 4 is equal to limit x tends to 0 whatever that is there in the bracket. But here there is an adjustment what we have made. So it is actually ln of 1 plus 2x e to the power of minus 2x. We wanted to write it as ln of 1 plus capital X by capital X. So that is 2x e to the power of minus 2x also we want to divide actually. Why? Because ln of 1 plus capital X by capital X, limit capital X tends to 0 will be 1. So to bring that 1, what we have done is um, already x is there. So 2x e to the power of minus 2x, to get it, to multiply the denominator by 2 e to the power of minus 2x, and to adjust that we multiply the numerator by 2 into e to the power of minus 2x. So also here minus x e to the power of minus x, we want x is already there. So we divide, we multiply the denominator by minus e power minus x. To adjust that one, minus into minus plus into e to the power of minus x will be multiplied by the numerator. So the adjustments are made here. And now the limit of this is one function, this is the other function. Therefore, limit of the sum of the functions is equal to sum of their limits. Limit x tends to a f of x plus g of x is equal to limit x tends to a of f of x plus limit x tends to a of g of x. So 1 by 2 into limit and this 2 is common in the numerator and the denominator. In the numerator 2 is there, that 2 cancelled with 2 times in the denominator. 1 by 2 times limit of the first plus limit of the second. So we carry forward. We have this one from the last slide. Now, limit of, this is the first function multiplied by the second function. Limit of the product of the functions is equal to product of their limits. So also here, limit of first function multiplied by second function, limit of the product is equal to product of their limits. So that will be equal to 1 by 2 into limit x tends to 0 of first function e power minus 2x, limit x tends to 0 of the remaining function. This is the fx, plus limit x tends to 0 of the first function e to the power of minus x into limit x tends to 0 of the second function. But we know limit x tends to 0 of e to the power of minus 2x is 1. Limit x tends to 0 e to the power of minus x is 1. So we are left with 1 by 2 into limit x tends to 0 of the first function plus limit x tends to 0 of the second function. Now we substitute capital X is equal to 2x into e to the power of minus 2x and capital Y is equal to minus x e to the power of minus x. Let capital X is equal to 2x into e to the power of minus 2x and capital Y is equal to minus x into e to the power of minus 2x. As x tends to 0, capital X tends to 0 and capital Y tends to 0. This may be observed from here. So note that capital X tends to 0 and capital Y tends to 0 as small x tends to 0. So the above one now becomes 1 by 2 into, in brackets, limit capital X tends to 0 of logarithm of 1 plus capital X by capital X plus limit capital Y tends to 0 of logarithm of 1 plus y by y. And we know it is a standard result. Limit x tends to 0 of logarithm of ln of 1 plus x by x is 1. So the first limit is 1, the second limit is also 1. We will get 1 by 2 into 1 plus 1 and that is the 1. That is our answer. Let's look at our options. And our answer 1 appears against the option 4. So our answer is option 4. So that is the discussion of the solution of a problem from differential calculus. And the problem is on the continuity of a given function at the origin. I hope that you have understood the solution of the problem. I wish you all the best. Thank you.